All right, so if you're using continuity to test the coil on your contactor, it may not be the best test to be using. So right now I got the meter on continuity, and I'm gonna go across the coil of this particular contactor, and I'm getting a reading of 115 ohms of resistance. And of course, we don't have that bell tone. And you won't get that bell tone because the resistance is a little bit too high. So I'm just gonna move it to ohms, and I'm gonna test it. Again, it's gonna have roughly around the same resistance reading, but I'm not going off of the bell tone. When I'm checking a coil on a contactor, I am looking for a resistance reading, and then I am comparing that resistance reading to the manufacturer specification of where that reading should be if the coil is to be good. However, if I go across my coil, I should not see OL if the coil is good. If you see OL when you probe against the coils, you have an open coil, and that is shot. Bad coil. And if you're unsure of your resistance reading, you can just apply direct power to your coil and see if it engages your contacts or not. So this contactor, the voltage it calls for the coil to work is 24 volts DC. I'm just gonna apply direct 24 volts using my power supply to this contactor coil. And you can see that it is pulling my contacts in. Like I said, always refer to manufacturer specification because not every contactor coil is the same. This one is a different brand contactor. It runs off 24 volts DC also, but it has a resistance reading of 55 ohms, which is about half the resistance of that one. This one works just fine too. I've tested before. But on this one, the resistance is low enough where if you would check it in continuity, you will get a bell tone. But then if the resistance on the coil is high enough, like on this one, you won't get a bell tone. So continuity is not the best testing method for you to test your coil or check your coil on your contactor. So until next time, deuces.